right, so we're going to look at a problem that reads, a penny is placed at the edge of a turntable, so a vinyl player, with a radius of 45 centimeters that's rotating at 25 rotations per minute. So part 1 asks us what's the angular velocity of the penny, and part 2 says what is the tangential velocity of the penny. Okay, so let's look at our picture. So let's imagine, ooh, I have new markers. Let's imagine that this is the turntable. We're looking at sort of a top-down view. And we know that this is 45 centimeters, so 0.45 meters that the penny is on at that point. And it says that the turntable is rotating at 25 rotations per minute. So it makes 25 complete circles every minute. All right, well, the first question is, what is its angular velocity? Well, rotations per minute is a angular type velocity, but we want to look at angular velocity in radians per second as our typical way that we look at angular velocity. So this is actually just a unit conversion. So we have 25 rotations per minute. If I remember that one rotation is 2 pi radians, and then I remember, of course, that there are 1 minute, and that gives, oops, not 30 seconds, 60 seconds. So although this is asking specifically about angular velocity, we want to recognize that that is an angular velocity in a different unit. This really becomes a unit conversion. And so we find that our angular velocity in radians per second is 2.62 radians per second. All right, part B asks, what is the tangential velocity of that penny as it's going at this rate? So we want to remember that the tangential velocity is equal to the angular velocity, omega, times the radius. So now that we have our angular velocity, 2.62 radians per second in the appropriate unit, doing that, times the radius of 0.45 meters, we find out that our tangential velocity is 1.18 meters per second. So, kind of working with these ideas of relating linear or tangential motion with circular motion. All right, good job.